The last type of problem we're going to look at for now is looking at graphs of a function and its inverse. Remember as we go through this that an inverse of a function isn't always a function itself. And we'll actually see that in this case. So we're going to look at what is the graph of y equals negative 2x squared plus 3 and also its inverse. Try to think for a second about what this is going to look like. Y equals negative 2x squared plus 3. Well, we have x squared. That means it's a parabola. I guess you could think of this as either vertex form or standard form right now. Really just your transformations that have happened to your parent function. This negative, that's our reflection. So it's going to make our parabola open downward. Let's start off by graphing this original function, negative 2x squared plus 3. If I think about where my vertex is going to be, I have a reflection over the x-axis, a vertical stretch, and our parent function has moved up 3. So my vertex is going to be at 0, 3. This kind of brings back some of the things that we're doing last semester in chapter 4 with graphing our parabolas. So here's our vertex. Now, normally our parent function, the vertex was 0, 0. My next point was 1, 1, over 1 and up 1. But now I have that reflection and that vertical stretch of 2. So instead of going over 1 and up 1, I'm going to go over 1 but down 2. Same on the other side of my axis of symmetry. Then my next point is usually 2, 4. So from my vertex over 2 and up 4. But since I have this vertical stretch and the reflection, I'm going to go over 2, and instead of up 4, we're going to go down 8. Right here. Here's my y equals negative 2x squared plus 3. Now, to graph its inverse, I could find out what the inverse equation is and graph from there. But in this case, we're going to end up with a square root, and we don't really know how to graph square root functions yet. That's actually our next section. But if we know their inverses, remember the biggest thing about inverses is that the x and the y switch. We can use that to graph our inverse. Our x and our y switch. So this point right here was 0, 3. Switch the x and a y around, 3, 0 is on the inverse. This point was 1, 1. Well, switching the x and the y around, we're still at 1, 1. This guy right here was 2, negative 5. Switch the x and the y around, we're at negative 5, 2. And then keep going. This one was negative 1, 1. Switch the x and the y around. That is 1, negative 1. And finally, this guy was 2, negative 5. Switch the x and the y around. Oh, sorry, this is negative 2. Switch the x and the y around, we're at negative 5, negative 2. So my inverse here looks something like this, my green line. And again, as I mentioned, my inverse isn't always going to be a function. It's not in this case. One other thing about inverses is that a relation and its inverse are reflections over the line y equals x. So what that means is, if I draw in my line y equals x, see if I have another pen here. If I draw in my line y equals x, and I should probably be using a straight edge for this. But if I draw in my line y equals x and folded my paper over this line, my green parabola, after I folded, would match where the purple is. And you can kind of see that a little bit here. Trying to get this under the document camera so it shows up. If you look at the top of my purple parabola, when I fold it over that line, it's matching up with my vertex of my green sideways parabola. That's not really a function, okay? And that's going to happen with all my other points. If you look at this green part of my parabola, when I fold that over that line, y equals x, that's coming down to match up with this purple leg, okay? So that's another big thing about inverses. Their graphs are reflections over that line y equals